Across the tropics, species are disappearing, but not in the way you may think. They're getting pushed towards extinction by essentially an unstoppable force. Recently, scientists published a paper that rocked the conservation community. The study took place on a remote Peruvian mountain range. In 1985, they did a survey, and they showed the elevational home ranges of 3 birds, the common scale-backed antbird in the low elevations, the versicolored barbet in mid-elevation forests, and at the top of the ridge, the variable antshrike. 30 years later, they came back and found that climate change had shifted the ecosystem. As temperatures warmed, the forest moved uphill. The common scale-backed antbird had expanded upslope. The versicolored barbet's range had also shifted upwards and shrunk by 2/3, squished against the top of the ridge, and the variable antshrike was gone, completely disappeared from the mountain. One thing is clear: climate change is forcing animals and plants to shift up in elevation to cooler areas. This is what the future looks like at the collision of climate change and biodiversity loss. Not necessarily with sudden natural disasters that tear apart ecosystems, but perhaps more dauntingly, it's the constant, increasingly unstoppable change, forcing life to move and adapt. And in some places, it's possible for life to adapt and animals to move upwards in elevation to cooler areas. But the scary thing is, 60% of tropical forests are disconnected due to fragmentation and human impact. And that means in many regions, biodiversity simply cannot move to respond to climate change. Their routes to resilience have been broken. And time is not on our side. But right now, an organization in Costa Rica called Osa Conservation is working on the front lines of biodiversity conservation and this climate crisis, developing and testing solutions in real time, solutions that, if successful, could be applied across the tropics. Join us as we jump to the cutting edge of conservation to learn how to build a wildlife corridor. It all starts here in the Osa Peninsula in the South Pacific of Costa Rica.
Osa Peninsula is the little Amazon of the Central Americas. And the Central Americas are located in the second most important biodiversity hotspot of the planet.
In Costa Rica, we think of the Osa Peninsula as a really remote place. But actually, it's really small. It's basically the equivalent of only 26 by 26 miles. But it's one of the most biologically concentrated places on the planet.
The Osa Peninsula hosts more biodiversity than what can be found in many countries. It also holds the elements of the next mass extinction. Climate change has ignited migration of biodiversity upslope. Already, wildlife is shifting towards the Talamanca mountain range in search of cooler climates. The problem? That migration is colliding into fragmented, deforested land. This intense concentration of biodiversity in ecosystems is not wilderness. It's intermixed across landscapes composed of palm plantations, cattle ranchers, and urban development. And the pathway from the peninsula up to higher elevation is completely cut off by a huge swath of agricultural land. The forest is too fragmented for animals to move. So how do we connect these landscapes together so that fauna and flora can adapt, while still allowing humans to live off the land? First is to look at the problem from above. Osa Conservation is working with an organization called Planet Labs through an initiative called Project Sentinella. It's a project designed to put high-resolution satellite imagery into the hands of conservation practitioners around the globe.
We have access to near real-time biomass data across our whole area of interest. And what the Planet data allows us to do is to extrapolate this out across the landscape scale and identify important pockets of habitat which may be really important for climate resilience and climate change.
It would be impossible to restore the connectivity of this area planting at random. It would take millions of trees and decades of planting. We don't have that time. We need to identify the best possible route for a corridor. With this imagery, Chris is able to calculate least cost pathways, maximizing forest coverage and natural restoration.
I'm like zooming in on tiny little patches of forest and saying, you can restore here, like this is where we're going to do natural restoration. This is going to be where we do active restoration.
Through this method, he's identified these model corridors that will connect the landscape in the most effective way possible. These plotted corridors will save decades of work. The team now knows exactly where to go, which landowners to talk to, and where to plant in order to complete these connections in years, not decades.
So that's incredibly powerful. And the other side of the coin is, it not only helps us design where to do things, but once we've done them, we can then go in and it facilitates tracking how these interventions change the landscape through time. And that previously would have taken years of survey effort going out, measuring trees, measuring tree height, measuring tree width, and making sure that those trees planted do turn into forest.
By tracking how a forest returns, the team can see what practices are working and which aren't. Anyone can plant a tree, but this tracking ensures that those trees actually become a forest. So the corridors are planned, but that means the work is just getting started, and there's a lot to do. The botanics team goes on seed expeditions, looking for rare and endangered trees to propagate.
The fruits, we're taking them to the tree nursery and then wait for planting season and go to a farm and grow into a big tree one day.
They fill 6 different nurseries across the landscape with over 300 different species of trees. The restoration team talks one-on-one with landowners, working with them to show the benefits of forest on their land.
Como lo bueno de ese programa es que se enfoca no solamente en la parte de restauración, que no es nuestra gran meta, sino la parte productiva, que es sumamente importante para al final asegurarnos a largo plazo que la gente va a seguir con este proyecto y que a través de esas mejoras productivas la gente quiere proteger sus ríos porque quiere proteger el agua, quiere proteger sus nacientes, quiere mejorar sus formas productivas para ser más eficientes y más sostenibles.
So far, they've gathered a network of over 300 farmers, building trust throughout the area, making sure the right trees are planted in the right place and maintained for generations to come. So the plan to build species-rich corridors to connect these vital landscapes is not only possible, it's already begun. The real question is whether these efforts actually change how a landscape functions. Tracking how animals are moving will allow us to understand the current state of connectivity within the landscape. But understanding the movement of wildlife is incredibly difficult in this remote, dense environment, and it will also take some cutting-edge technology.
So the species which we work with, they cover vast distances in very short amounts of time, and we have no idea of what they're doing or where they're going or how frequently they're doing things.
The team first focuses on one of the most important animals in the ecosystem. Vultures perform vital services. As nature's cleanup crew, they greatly reduce any diseases in the environment and also redistribute nutrients back into the landscape.
In the last 4 years, we have captured more than 90 vultures.
5 black vultures and 1 king.
So, the species which we're tracking have, some of them, particularly the vultures, the king vulture, the greater yellow-headed vulture, they've never been tracked before with this kind of technology. So this is one of the first ever movement ecology projects on these species. So everything that we get is new information, and that is really exciting.
The team takes samples to see how healthy the vultures are, as they are incredible indicator species. Everything they find is essentially new to science.
And we're also installing these GPS transmitters on each king vulture or turkey vulture that we capture. It's an incredibly cool little piece of technology. It's a solar-powered, GSM-enabled transmitter. It can tell us so much about their behavior and their movement, how they're using the landscape.
He's gonna fly really fast.
When the field team puts on a harness, my job actually starts instantly. Probably within a couple of hours of a device going on in the field, I'm already bringing in data. So every single day, I'll pull up my locations and I'll check out what all of our animals are up to. So we've got animals doing interesting movements every single day. We tagged all of our individuals down in this part of the map down here, is the Osa Peninsula. But you can see Mufasa has traveled probably 150 kilometers away. But one of the really cool things about the bird data is they're not just 2D. And the really cool thing about all of our bird transmitters is they also give you height information. Each of these individual colored lines is actually the movements of a single individual. Some individuals are flying quite high, some individuals are flying a lot lower. And we can start to ask questions about how high do animals fly? Why are they flying at these different heights? What are the predictors of that? And what are they doing when they're flying so high? When you're looking at this data every day, you can tease out patterns and processes. And the really interesting thing is they don't really cross into Panama. There's almost this hard border between Costa Rica and Panama. This is what we'd call a heat map of vulture activity across our area of interest in Costa Rica. This is the border with Panama, okay?
Immediately when we overlaid a land use map on top of the layer of our king vulture movements, it was so clear to us that land use, that deforestation, was the cause of that movement restriction going into northern Panama. They are not using areas that are completely cleared. And in fact, when we broke it down a little bit further, we found out that king vultures will not cross between two patches of forest that are more than 20 kilometers apart.
So already with king vultures, we are seeing that they need connected forests in order for them to perform their essential services. But what about other animals? And the team also wants to look at predators.
Predators are really important because they are at the top of the food chain. So they keep the ecosystem really healthy and balanced.
The top predators here are cats, and they're also some of the most elusive animals in the forest. The only way to really understand where they go and how they use the landscape is to fit them with temporary GPS collars. And to do that, they need to capture them.
Every day we are ready for a capture. In these circumstances, first we get an alarm and we go out into the forest to make sure that it's a cat that we have in the trap. We put the anesthesia and then the process starts. We got a new ocelot. Once the animal is under anesthesia, make sure that everything is fine, is healthy, and we start the process of putting on the collar, while also we do monitor the health status of the animal. We take samples.
The collar will stay on the cat for 3 months, taking location points every 2 hours before falling off.
After about an hour, the cat is ready to be awake, so we help her with a reverser and she's ready to leave. For me, the best part is when the cat awake and then leave. We can start seeing the mysteries of their lives.
The team has successfully placed collars on 7 ocelots, collecting thousands and thousands of data points of new information.
And then we can start seeing how the animal is using the landscape, and all the mysteries that we have is now there in a map. Right now, the predators that we tag, like pumas and ocelots, they face some threats, like roads and cattle farms. You can see in the map that they stop from going to the cattle farms. Basically, they go into the edge, but they don't go to those places. As we gather this information, we are gonna understand how they are using fragmented areas and restoration areas, and we're gonna understand how we can build better corridors for them. And more incredible, we have collars that have camera on, and we have even more detail of how they are using the landscape. We put a camera collar on a puma named Tico. It was the first time for a puma in the tropics. So the information that we got, it was so excited. We even saw him mating with another puma that we collared. A puma love story. It's incredible the things that we already learned. The truth is that we're just scratching the surface of the things that we don't know, and we still have a lot of things to do.
This area is not just important for the protection of biodiversity, but this is the landscape that can prove that humans can live out of using nature in a very wise manner. Today, in the Osa Peninsula, nature-based tourism and conservation activities are the #1 source of jobs, which is something that you don't see anywhere in the world. So you got these dual opportunities of protecting nature and using nature as a driver for growth, stability, and well-being of the people.
In the final step, we look towards the future. All this work is meaningless unless the next generation takes on the stewardship of the land. With the Montaña Mar Youth Nature Club, the mission is to foster a love for nature and conservation. Over 1,500 children are taken on adventures exploring all the incredible ecosystems of their home. Despite how close it is to them, many of the children have never been to these habitats or seen certain wildlife.
¿No he visto antes una ballena?
¿Ya has visto una ballena?
No.
¿Nunca has visto una ballena?
¿Has visto una ballena antes?
No.
Mi amor, ¿tú has visto una ballena antes?
No.
¿Y quieres ver una? ¿Quieres ver ballenas?
¡Sí!
Through these experiences, we hope to inspire the next leaders of conservation in Costa Rica. And it's working. Many of them are already becoming strong voices in their community. There's still a lot of work to do. Whether you're interested in growing back rainforests, expanding rewilding efforts, or inspiring the next generation of leaders to continue the mission, you can join us. If you want to see this work continue, every bit of support goes directly into building coexistence. It takes a lot to grow a functioning wildlife corridor, blending technology with on-the-ground biology and restoration, and fostering the love for these ecosystems throughout the social fabric of the landscape. But once these corridors are complete, they will be bridges that not only connect biodiversity to resilient habitats, but will also connect people to nature and create sustainable livelihoods, a world where humans and nature are one and resilient for generations to come.